All right, so we'll be covering chapter 10 today. Sorry again, last class was a little bit short. When I was sort of doing the schedule, I didn't realize there was a 20-page chapter in the book, so let out a little bit early last class. Maybe we won't be able to this class, we'll see. But of course, covering routing protocols, going a little bit more in depth, talking a little bit more about what this process looks like. So before we jump into that too much, I just want to remind you, we have a review on Friday, and I'll go ahead and make it optional. So if you have any questions, feel free to attend. But if you don't, just feel free to not. Basically, it's going to be a multiple choice test. I'll probably make it right around 25 questions. Not going to be like a crazy long test or anything. Make sure you review the book. You guys have the book, right? Okay. So at the end of each chapter, have you guys seen the chapter summaries? Those are important. Also important for the exam, make sure you review the practice questions for each chapter. I'm pretty sure it has the answers in it. So, that'd be a good thing to look over. Sorry about that. So certainly make sure that you do that. Apart from that, I think you all won't have too many problems as long as you understand the first 10 chapters. Shouldn't be anything too bad. So, you guys good with that? Optional class Friday. Like I said, we won't have an agenda. I just pretty much told you what the exam will look like. So, yeah, pretty straightforward. If you want to see a sample question, look in the book. Not saying it'll be the exact same questions, but it might be. You never know how lazy I may be. Anyway, covering routing basics. We covered that, just kind of a brief review from last chapter. Different routing protocols, distance vector, link state, all this sort of thing. High availability, something we'll be covering. It's an important topic. Even for a small business at this point, it's important to have redundancy built into our network topologies. Covering a little bit with IPv6 as well. So just kind of review from last class. We have autonomous systems, and it's going to be sharing the same administrative domain. So in general, you have a big network. Depending on how you configure, maybe one, maybe more than one. But it's basically going to be interchangeable with WAN. Okay, then you have interior gateway protocols. We're using one administrative system. So up here, you can tell we have different types of IGP. So we have distance vector, which we'll talk about. We have link state, which we'll talk about, as well as hybrid, which obviously is a combination of distance and link state. Okay, you also have exterior gateway protocols. It's where you're using multiple administrative, or not administrative zones, autonomous systems. Okay. Just a brief review from last class. So, kind of looking at the administrative distance, this is all about how reliable do we think the connection will be to get there. So, we have a scale from 0 to 255. 255 being a number we'll see a lot in here. So, if you have something that's 0, it's going to be the best possible route. If you have something that's 255, is it even going to be possible to get there? In most cases, it would not be. 255, we'll talk about that in a little bit, but basically that's meaning that we don't know the path to receive, so we assign 255 to it. The book says you'll never use 255. I would disagree. I think there's some cases where you may, but it's going to be pretty rare. If you are using 255, you're going to have problems. So basically what this is doing is, assuming we're not using static routing, we're in dynamic routing, this is going to help us sort of determine what the best path should be. And there could be some cases where you have two routes that are both 20. And if they're both rated at 20, then we're going to use other metrics. So let's say we have a case where we have a path that is rated at 20, and we have a path that is rated at 50. Which is it going to use? 20. But if we have two paths rated at 20, it's going to look at other things. It could look at a lot of different things. It could look at a ping time. It could look at the number of hops. It could look at just a multitude of different things. It's all going to happen automatically. And if everything else is equal, it's going to be possible that they could all be equal. Because the ping on a small network, is it going to be much different? Or measuring in milliseconds, it's not going to be much different. Number of hops, that could certainly be the same. And there's a couple other things we could look at as well. It's very possible they could all be the same. If we do have that case occur, then we're just going to use load balancing. So sometimes it'll go one way, sometimes it'll go another way. And there could be more than 2 potential paths. So, basically just load balance everything. Does that make sense? So this is it right here. That's a great question, Ben. Basically, there's going to be some default sort of administrative distances applied to stuff. So if you're on a connected interface, meaning that you have a direct connection, like you're not going through a router or anything, it's basically a local host at that point. It's going to be 0. Okay, and like I said, if it has no idea what path it should take, it's going to be a 255. It means it can't necessarily reach it. If it's 255, probably never going to use it. But I would say probably because you may. And of course, we have different sorts of paths along here. Static route. So of course, if we're using static routing, then we know that that's what we're always going to use because we have gone ahead and applied static routing. So that's going to be 1. We don't want to overwrite that. Does that make sense? So using some other internal IGP, where it's going to be much larger than that. So we have Egrip, Egrip, OSPF. Those are all, of course, IGP dynamic routed protocols. RIP as well. And the reason that Egrip is rated better than, say, OSPF, because it's faster. Also at the same time, think about it. Are you going to have a network that's using some Egrip and some OSPF? Probably not. That's pretty rare. I wouldn't rule it out, but if you think about, are there any advantages to using both protocols? I could think of a few. So of course we know Egrip is a Cisco proprietary protocol. Let's say you're a firm that uses some Cisco and some HP. Anyone think of any examples of a company like that? Or I won't say company, an organization like that? How about Fort Lewis? They use some HP networking equipment, some Cisco. So in that case, you may have some stuff being routed via Egrip. You may have some stuff being routed via OSPF. But because Egrip is faster, it has a smaller number there. Does that make sense? So I don't really see a big reason to memorize this, but make sure you kind of understand the order and sort of the logic behind it. RIP is very slow, so obviously it's going to be a lot, it's going to have a larger number. OSPF is kind of in between. That's why it's kind of in between the two. So like I said, pretty straightforward here. But this is default. There could be some differences. So, it's a little bit beyond this class, but for now, just understand that this is happening automatically if it's a dynamic routing, and it will be. So, like I said, it's pretty rare to run into a company that's using only static routing in 2021. So, some different classifications of routing protocols to know. There's 3 for IGP. We got distance vector. Basically, distance vector is exclusively looking at how many hops there are. Of course, we define a hop by going from one router to another. So if we have just a simple little network here, got our little host machine. Okay, I got a router A. Let's call it router 1. Okay, it's 1 hop. Make sense? Okay, you got to go to router 2. 2 hop. Okay, you go to host B. But let's say for whatever reason, we had a 3rd router in the mix. Don't know why we'd have a topology like this, but let's say we did. All right, does that make sense to everyone? So now, if we're using a distance vector, are we going to use this guy with 2 hops or this guy down here with 1 hop? 1 hop. What's that song that goes, 1 hop this time? You guys know what I'm talking about? It's like that. Not really like that, but just think about that. So some examples of protocols that are distance vector, RIP, RIP-v2, and Egrip, not to be confused with Egrip. This is like an older version. The new Egrip is, of course, enhanced Egrip, so make sure you understand that. Link state is going to be a little bit different. So link state doesn't exclusively look at the number of hops. I have an example here. There's 3 different tables that it's going to form. Okay. So the first table up here, it's going to be the neighbor table. It's going to tell it what is the next router that I could connect to. So if I were router 1, I would have a neighbor table with router 2. And let's just put a link down here, why not? So router 2 and router 3. Does that make sense to everyone? That's what's going to be in that first table. Okay, then it's got the topology of the entire network. So it doesn't just have its neighboring routers, it also has the entire network. Now, would you have 3 routers and 2 hosts? Would that make any sense? Not really. But this is, again, just a basic example. I'm not going to draw a realistic network with thousands of hosts. I think you all appreciate that. Then lastly, it's got the actual routing table. So that's going to be something it builds. So it's going to base it off of these 3 tables. It's an algorithm in place. We'll talk about that in a little bit. But for now, just understand the basics. So examples of that are going to be OSPF and ISIS. And like I said, we'll talk about these in more detail. And of course, also, we have hybrid, where, it's not just using the number of hops, and it's not just using the topology to sort of determine it. It's using both. Generally speaking, these are going to be your faster protocols, but don't get too caught up in the speed, because again, on even a mid-sized network, you're not going to notice a big difference. So you got Egrip, BGP, and IBGP. And realistically, you can make an argument that only IBGP is truly a hybrid. I'm not going to debate the semantics with you, but you could make that argument. So if I were going to ask an exam question, I wouldn't be tricky and ask whether BGP were a hybrid or not, because that's pretty tricky. You can make a case it is, you can make a case it is not. Technically speaking, IBGP is an implementation of BGP, therefore it is. That's my interpretation of it. You can have different interpretation. It's up to you. But basically, it's just going to use both of those. Any questions so far? Okay, so now we have distance vector routing. So we've kind of talked about the various IGP. It's where routers are going to share their routing tables. Now, the obvious issue is, what if you have a malicious router? So is it possible for someone who's nefarious to go into your organization, plug in a simple little router? I don't see why it wouldn't be. So basically, there's no verification to verify the routing tables are correct. So would it be possible to load up that router that is malicious with, say, fake routing tables? It is. So no verification could be a very big problem here. Does that make sense? Because imagine if someone were nefarious, they want to plug up something just to kind of mess with you. Maybe they don't like you. Maybe they don't like your company. And then basically what happens is, instead of just looking at neighboring routers like some of the other protocols, they're actually going to sort of converge their tables to each have the same table. So that's why the no verification is a big problem. Because if one router says something, it gets pushed to all the routers. Does that make sense? So we'll see an example of that. But basically, what this is going to do is use the least hops as well. So basically, if there's a case where it's equal, round robin load balancing, sometimes it's going to go one way, sometimes it goes another way. Here's what this process looks like. Up here you have 4 different routers. Each of the routers have their own routing tables, and then through this process, they're going to share all of the routing tables. So right now, you see this router right here only has its immediate neighbor, and this router only has its immediate 2 neighbors. Does that make sense? So basically, when they share those tables, they get them all. So that's all we're talking about here. Router information protocol, it's an old protocol. You're unlikely to see a modern enterprise network using it because it has a ton of downsides. In fact, there's not really many upsides. It's slow. It's very inefficient. It only updates every 30 seconds. So let's say something is down. Okay, do you want to wait 30 seconds to figure that out? Probably not. It's also, of course, a distance routing protocol, so it's only going to use the number of hops, which, isn't the end of the world, but what is the problem is there's only 15 hops, okay? So is it possible to have a network with more than 16 routers? Yeah, absolutely. Is it likely that you'll run into networks with more than 16 routers? Well, depends on what you do. If you're a network engineer working for a large firm, yeah, I'd say it's almost guaranteed. If you go into a different career, maybe you would, maybe you wouldn't. Who knows? But I think at some point in your career, even if you're not a network engineer, I think you'll probably run across some network with more than 16 hops. So having said that, anything 16 or more is unreachable. That's a pretty big problem, isn't it? So how do we avoid that? We don't use RIP. That's pretty straightforward. Wish everything was that straightforward. This is also going to be classful routing, which is another disadvantage. So classful routing means that everything that it's routing must be on the same subnet mask. So that's a pretty big disadvantage. Are there any advantages to using it? I think you can make a reasonable case that it's supported on pretty much any legacy technology you may have. Having said that, why would you be using legacy technologies in an enterprise? Well, there's a few reasons. Could be some old equipment that you have that's only supported on certain versions of whatever, and maybe that equipment would be very expensive to replace, very common in manufacturing. You'll still see a lot of manufacturing systems, running stuff like Server 2003, Windows XP, even older than that in some cases. So, it's not unheard of to need to use an older protocol. Having said that, let's say you're a modern enterprise that's only using, modern equipment. Would you ever use RIP? Not on purpose. Maybe you accidentally use it, but probably not. Okay, distance. So RIP v2, still a distance vector. Basically just RIP. It's still classless. It still has max count of 16 hops. The only thing is it adds support for stuff like multicast, which could be useful. VLSM, which we'll talk about in a little bit, and then MD5, of course, for verification and authentication purposes. So it's still really not that useful in modern networks. Okay, but VLSM is certainly a very useful thing. Okay, so VLSM is, of course, variable length subnet mask, and this is where we're going to support classless routing. So basically, the whole thing here is that instead of having to have all the subnets be the same, we can use different subnet sizes. Okay, so this is going to guarantee us some pretty big efficiency, because imagine we had all these different subnets. Okay, we have one subnet with 25 hosts, one with 6. Do we want to have 27 different addresses being used when we only need 6? It's not very efficient. I personally would argue it'd probably be a lot easier to manage, but in terms of efficiency of addresses, it could be an issue. Of course, it's easier to manage because is a subnet of 6. Do you think that will ever grow? So do departments stay the same size? No. Generally speaking, most departments are going to eventually expand. So if you had each department on a different subnet, which I'm not sure why you would do, but let's say you did, just from a theoretical standpoint, you definitely want to be using VLSM. Having said that, like I say, always have a little bit of room to grow, because you want to reconfigure a network and redo the subnet mask every time you get a new employee. You definitely would not. In fact, why is this using Class C at all? I don't really know, but it is. Class A would be a lot better because then you have so many more addresses to work with. But of course, it's going to be supported by RIP v2, Egrip, and OSPF. So, talk about discontiguous networks a little bit. This is where you're going to have 2 or more classful subnets connected by different network. So we got Class A, or host A over here, on this first subnet. We got host B on the second subnet here. And basically, they're classful, but they're going to be connected. So, something that is only supported really by OSPF. It's not really a huge advantage to this over using a VLSM, but just know it exists and know what it is. Does that make sense to everyone? We got 2 different subnets. They're still connected. Okay. Egrip. Egrip's a great protocol. The biggest downside is that it's Cisco proprietary. But it's going to support hybrid routing, so it's not just using distance, and it's not just using other things. It's scalable and fast. So we're not just tied down to being on the same subnet mask. It's going to be classless. Classless is very good. Of course, it's going to support VLSM. Supports IPv4 and IPv6 on the same database. So I think it's OSPF that does not support it on the same database. So you're basically running two separate instances, which is going to be more taxing on hardware. Egrip is going to be more efficient on hardware. The downside is you have to use Cisco. It's also going to have support for CIDR. So pretty much anything will support CIDR. I wouldn't be too concerned with that, but just know that it does. Border Gateway Protocol. So as we think back, this is going to be not IGP because we're connecting different autonomous systems. So we're going to use BGP for that. So we have one autonomous system right here. Of course, it's got all of its IGPs. You know, I would say you're either going to be using Egrip or OSPF, most likely. Why would you use Egrip and not Egrip? Is there any reason at all? Well, it kind of goes back to the legacy point. If you're using legacy equipment, I mean like 20 plus years old, maybe you would use Egrip, maybe you would use RIP. But most modern networks, you should definitely be using Egrip or OSPF. I would go so far as say if you're using a Cisco network, not really reason to use OSPF. If you're using a network that doesn't exclusively use Cisco, OSPF's the way to go. Does that make sense? So, you know, there's very few reasons to use RIP. It's slow. Like I said, it's just not good. Of course, it's going to be classless. Why would it have to be classless? Would it even be possible to use something that's using external, you know, separate autonomous systems? I mean, why on earth would they have the same subnet mask? It's possible, but it's very unlikely. So, you know, if you think about this, we can actually use this to sort of mitigate some of the downfalls, specifically the number of hops. Because what you could do is you could, when you're designing your network, if you wanted to, like I said, it's not a big reason you would do this, you could design it in a way to where you had 16 hops, you just get rid of that, you just make separate autonomous zones. So autonomous systems, I mean. So then you could put a BGP in between them. But why not just use a protocol that supports more than 15 hops? Doesn't that make a lot more sense? So I'm saying you could help using RIP and RIP-v2, but you're very unlikely to ever come across a scenario that would make any sense at all. All right, open shortest path first, like I say, OSPF. This is going to be not a proprietary protocol. It's going to be linked state. It's going to be free to use, basically. It's using this algorithm right here. Anyone want to take a stab at pronouncing that? Any guesses at all? I don't know the answer either. I wouldn't ask you to pronounce it on a test. How about that? You know, let's just call it the D algorithm. Okay? And basically, there's two major steps that it takes. Okay, first, it's going to look for the shortest path. Okay, then it's going to look at the routing table. So, really straightforward there. It's going to take the best path based on those two things. It's going to be slower than Egrip, but it's going to be faster than RIP and a lot of the other protocols. So I call it moderate speed. You could make an argument, you know, that it's going to be faster than most things. So it may be high speed, but I just called it moderate because I call the others slow. Is that fair? So you either got the best, you got the worst, or you got in between. We're in between right now. This is where we're having some support for IPv6. It is supported, but like I said, the downside is that you're running two separate databases. And when you're running two separate databases, you're looking at two different things. So you're running stuff twice as much, basically. So this is going to have a lot of overhead if you're using IPv6. Not to say that this wouldn't be a great protocol to use because, you know, modern networking hardware, it's pretty robust. It's pretty capable. So even though it is going to have some additional overhead, it wouldn't necessarily be noticeable, especially on a medium or a small network. On a large network, yeah, it probably would be. But on a large network, why on earth would you be using IPv6? Is there really a big reason to? I don't know the big reason to. I mean, sure, there's some advantages of IPv6, but on a large network, you're going to have so many different devices. You may have, you know, millions of different hosts. are you going to make sure that each of those millions of different hosts support IPv6, or are you just going to roll out good old IPv4? Which one would you do? Who votes IPv4? Who votes IPv6? Who isn't sure? Okay. So, if you're talking about having millions of hosts and all sorts of crazy things that happen on a corporate network, it'd be difficult, not impossible, but very difficult to do IPv6. There are very few networks out there that are IPv6 exclusive that have more than a couple thousand hosts. Does that make sense? There's going to be a lot of hybrids. There's going to be a lot of tunneling stuff happening, a lot of stuff like that. But in terms of just a completely IPv6 network, it's going to be difficult to do. Because, let's face it, even in 2021, what's the default? That's exactly right. The default is IPv4. So you have to manually go in, or you could do it. There's lots of different ways you can do it, but it's going to be a lot more work to do IPv6 exclusively. So here's what we're looking at. We got a backbone router, we got our area border routers, and then we got our autonomous system border routers. So basically we can go one of those, and like I said, we have the different areas, of course, for different autonomous systems. We can support them, of course, but we have to have additional routers and stuff. This is going to have lower amounts of update traffic than, say, some other protocols like RIP. I really just like to rip on the RIP protocol. How about that? I won't quit the day job, but it's going to be a lot more scalable. Now, it's going to be pretty much equally scalable to Egrip. So, like I say, there's no reason you wouldn't use Egrip if you're Cisco exclusive, unless you have some, let's say you had a moral objection to proprietary standards. I'm not going to ask if anyone does have a moral objection to that, but some people do. Personally, I consider myself to be more of a pragmatist. I'm not going to worry about making sure everything is open, but some people are that way, and that's fine. And if you are, well, then you probably wouldn't want to use Egrip, even if you had Cisco equipment. Having said that, would you even buy Cisco equipment in the first place? Well, you'd be kind of ideologically inconsistent if you did. Cisco, of course, known for their proprietary standards, known for a lot of proprietary hardware, also known for a lot of innovation. Let's face it, a lot of the innovation, I would go so far as to say, easily 70–80% of network innovation comes out of Cisco. Does that mean you should go buy Cisco? Of course not. But, it's something that is leading to a lot of innovation. So make of that what you will. Got off topic a little bit. It's going to support VLSM Insider, obviously. Unlimited hop count, it's a big advantage. It's going to be scalable, like I say. Pretty straightforward. It's an open standard. Like I said, it just kind of explained why that's an important thing. You don't have to be limited to one specific vendor of networking equipment. Why is that a good thing? Like I say, ignoring the ideology, I don't care about the ideology of it. Just from a financial standpoint, why is it a good thing to have an open standard? Could be cheaper. Let's say you're dealing with a vendor. Let's go call this vendor HP. Okay? And they start to raise their prices on you. Okay? Do you want to be able to be stuck with them, or do you want to be able to go to another vendor? Go to another vendor. Go check out what Aruba's doing. I did not write that very well at all, did I? Okay? Maybe Aruba will offer you a better deal. Basically, if you're stuck into a proprietary protocol, this goes for anything in IT. If you're stuck into something that's proprietary, that got you locked in. Your switching costs are very high. If your switching costs are very high, it means that they can give you less favorable deals. That's why, in my opinion, open standards are a good thing. It's one of the reasons. I mean, obviously there's others. But from a business standpoint, that's why. You're not locked into a vendor. Is Cisco equipment on the whole, is it very inexpensive or very expensive? Generally speaking, it's going to be more expensive. Is it always more expensive? Of course not. There's always going to be different deals that you can get when you're purchasing in bulk. You guys understand economies of scale, of course. I'm not going to go too much into that right now. But just understand that. So does that kind of make sense why open standards could be a good thing? No. Are there some downsides to open standards? Maybe. You can make an argument that open standards tend to have less resources devoted to their development. I think it's a fair argument. Think about something like SSL. You guys remember the heartbeat vulnerability? So the heartbeat vulnerability, of course, was there for years. And you know what? No one noticed. It's an open standard. But, there's probably also going to be vulnerabilities in proprietary stuff. It just never gets released. Take, not Cisco iOS, take Apple iOS. Is there a single version of iOS that companies aren't claiming they can breach? Is there one version? No, there's not. There's multiple different backdoors that are known to certain parties. And, so that's an example. What about Android? Are there versions of Android? I'm not talking about the different proprietary, I'm talking just Android open source project. Are there versions of it that have no known backdoors and vulnerabilities? Yeah, there are. So, it's just kind of, there's no right answer. It's going to be very specific to a case. I wouldn't go so far as to say open standards are better or worse than a closed standard. Does that make sense? So like I say, have your own opinion about it. I really don't care what you think of open standards. What is important, though, is talking about ISIS. Intermediate system to intermediate system. So instead of having a bunch of border routers, we have level 1 and level 2. Level 1 is going to be for communicating within the autonomous system. Level 2 is going to go between different autonomous systems. So each of these areas has a level 1 and a level 2 router. Obvious downsides to this are that you have to have basically double the number of routers. Is that a good thing? Well, when you're talking double the number of routers, it's important to realize that you also not just have the production routers, the ones actually being used. So Cisco calls them active in their Egrip, so you have, let's just say, double that. But you also, of course, have double the redundant routers. So that can get pretty pricey. There are reasons you would use it. Of course, it does have better IPv6 support than OSPF, but that's not hard to do. Okay, speaking of redundancy, got the concept of high availability. So with high availability, the whole purpose is that if one router goes down, your whole network doesn't crash. Is that a good thing? Absolutely. Imagine you were an engineer at Facebook yesterday. You think that'd be a fun day to be working? I would say almost certainly not. I'm certainly glad I'm not over there. But I just understand what we're talking about here is first hop redundancy protocols. This is where we're going to be able to have multiple physical routers. So we've got multiple routers. Okay. And they're each going to have a virtual router associated with them. So they can share that virtual router. The virtual router is going to have its own IP address and its own MAC address. Now, I should note the MAC address is a virtual MAC address. It's not a real MAC address. Well, let me rephrase that. It's not a hardware MAC address. Does that make sense? So there's no actual network interface card on a virtual router. So you're basically applying a random MAC address, or somewhat random. Not really random. But you're applying a MAC address to this. And basically the protocol is going to determine which physical router the packets get sent to. For most of the different protocols that are using high availability, most of them unfortunately only send it to one. They're not really load balancing, they're just sort of, if this one router's down, it goes to the second one. Does that make sense? So that's mostly what they're doing. Of course, we have a hot standby router protocol, so Cisco proprietary protocol. Come across a lot of those, of course. And they use the term active and standby router. So the active router is the guy who's getting all of the different requests sent to it. And basically, there's going to be a timer, and it's called the HSRP timer. And if the timer goes off and it's not able to reach the first router, the active router, it's going to go to the standby router. Okay, and you can have up to 7 standby routers for every active router. So the book makes a joke about this is Cisco's favorite protocol. I don't know if it's Cisco's favorite, but I'm sure they like it. It's like I say, only using the active router. This is not load balancing. Does that make sense? So like I said, here's what you have. You have a host here going to their default gateway. A request gets routed to the virtual router, which of course routes it to the active router. which then sends a request out, and it happens that way. Question? That's really speculation that I wouldn't really have any insider information about. My guess is that this is an older protocol, and load balancing was probably less capable when you're having like 8 megabytes of RAM, for example. Because that's 20 years ago, that's what routers had, like 8 megabytes of RAM, sometimes 16, but not a lot. And that's like, actual enterprise router. I'm not talking about some piece of junk you go buy from Walmart. I'm talking like an actual enterprise router. It'll be very limited in its capabilities. That's just my guess. In modern time, I think that, there are other protocols we could use that would have load balancing. You can also, of course, use load balancing with HSRP, for example. It's just by default the protocol doesn't support it. There are other ways to do it. Does that make sense? Any other questions? All right, so of course you have an open standard as well to kind of complement what Cisco did proprietarily. It's VRRP, Virtual Router Redundancy Protocol. And it basically does the same exact thing. It does not load balance, only it has a master instead of an active. Now, what is the master? It's the active. They're the same thing. You have your standby, that doesn't really change. But instead of calling the active, they call the active the master. That's kind of interesting. You have, of course, more than one standby. It's really up to you. And routers don't have to be expensive, even enterprise routers. Think about something like an Edge Router X from Ubiquiti. Those are like, what, 50 bucks? Not that expensive. Think about something from Microtik. You can get stuff under $50 probably there. You have different options. Will they be, as fast as, $2,000 or $3,000 router? Obviously not. But would they be able to support gigabit routing? Absolutely. So you've got different options. That's basically VRRP. Of course, you also have the concept of router advertisement. We talked about this. This is basically where you have self-assigning IPv6 addresses. So what happens is the host is going to, over ICMP protocol, it's going to request the default gateway's prefix. It's going to go to its default gateway, get that prefix. Of course, the default gateway is going to return the prefix. And then the host generates the IPv6 address. Like I said, we talked about this. I'm not going to go very far into it. Here's just a little picture of it. And obviously, it's going to use its MAC for a big chunk of that. MAC address, of course. That should be a little more specific. Neighbor discovery. This is something that's needed because, as we know, IPv6, we're not doing a lot of broadcasts. The book says IPv6 ends broadcast. I don't agree with that. I think it ends most broadcasts. I say it ends all broadcasts. I mean, it's just not true, but that's okay. So what's happening is you're transmitting link local instead of using MAC. And the obvious reason for this is the MAC is part of the link local address, so why would you not? With this, you're going to be using the prefix FE80, and basically it's just going to be using multicast. So is multicast a form of broadcast? Yeah. So like I said, it doesn't eliminate it, but you're not doing stuff like ARP on IPv6. Does that make sense? So it reduces it, but it doesn't eliminate it. So like I said, here's what that sort of looks like. It's not an ARP, but it's similar. So you're basically just using neighbor discovery. And like I say, I recommend that you try this out. Use some packet capture tool like Wireshark and just see the actual process taking place. It'd be kind of fun to configure an IPv6 network just for testing. So not a requirement for this course or anything, but I think it'd be good to do if you get the chance. Okay, some different IPv6 routing standards. RIP-NG. You guys loved RIP so much. We got RIP for IPv6. Does it fix any of the downsides of RIP? Not really. That's kind of the funny thing about it. It's using this prefix right here, FF029. And then, of course, we have Egrip v6. It's using the same sort of advantages that Egrip offers, which are very many, as well as with a couple downsides. Still Cisco proprietary, supports IPv6. I would argue it's not really a separate standard because you're basically using modern Egrip. It's going to support IPv6. But this is the prefix you would use there. As well as OSPF version 3. This is a little bit different. The main thing is that it has a separate routing table for IPv6 addresses. And of course, it has the prefix FF02 6. Does that make sense to everyone? not a whole lot changes in what we talked about before. They just have different prefixes that obviously are going to be supported by IPv6. And yeah, apart from that, there's not a huge difference. So I'll just kind of wrap things up. We talked about the various routing protocols, talked about a little bit of routing basics, talked about distance vector and link state, talked a little bit about high availability protocols, and a little bit more with IPv6. Any questions? Like I say, I will make class optional on Friday. I don't have an agenda. Maybe if you just want to review the book, that's probably going to be a really good bet. Kind of leave that up to you, how you study. But if you have any questions, I'll be here. Apart from that, have a great weekend if I don't see you Friday.